today's lesson is known as integration by parts. Integration by parts is a technique that you could use to solve an integral. The concept of integration by parts was derived from the product rule. So let's look at the idea behind the integration by parts. So let's assume that we have a function called u times v, and we want to take the derivative of this. Then we will have to use a product rule. So it will be u prime times v plus v prime times u. Inverse of a derivative is integration. So we're going to integrate both sides of the equation. So integral of the derivative of u times v and integral of u prime times v plus v prime times u. And again, we're going to integrate in respect to dx. So integral and the derivative will eliminate each other. So we're left with u times v. Now we're going to look at this two different equations. We're going to look at it as integral of u prime times v dx plus integral of v prime times u dx. Again, just keep in mind u prime in this case is equivalent to du over dx, and v prime is same concept, dv over dx. So if you change that around, we'll have integral of v times du plus integral of u times dv. We could say that integral of u times dv is equal to uv minus integral of v times du. And here's the rule of integration by parts. So here is the integration by parts. Okay, we're assuming that if u and v are functions of x and they have a continuous derivative, we could say that integral of u times dv is equal to u times v minus integral of v times du. Again, you're given as a definite integral in this case. If it's indefinite, you will just have to get rid of that intervals. It says find the integral of x squared times ln of x dx. As you can see, those are two things that are getting multiplied, x squared and ln of x. Our thought process should be try to use u-substitution, and if it doesn't work out, we have an integration by parts to try. So we could see that u-substitution wouldn't work in this case. So we're going to try to use integration by parts. So before we said integration by part was integral of u dv is equal to u times v minus integral of v du. So that means one of these functions have to be a u and one of them have to be dv. I'm going to say u in this case is equal to ln of x. So if this is your u, the remaining terms will be your dv. So we're going to say dv is equal to x squared times dx. So notice that we will need du and v. So we will take the derivative of u to find out du. We know that derivative of ln is 1 over x. And integral of x squared is x to the third over 3. So we're solving for integral of ln of x times x squared dx. Again, I rewrote it because we called u as ln of x, dv as x squared dx. So I just rearranged so you guys could see it better. U times v minus integral of v times du. So in our case, our u was ln of x, our v was x to the third over 3. Once again, integral of v, so it'll be x to the third over 3. And du in this case was 1 over x dx. Don't forget, when you take the integral of u, you should have had dx there. Now we will simplify this integral to solve it. So we will say integral of ln of x times x squared dx, again our original equation, is equal to ln of x times to the third all over 3 minus the integral of x squared over 3 dx. And now we have something that we could integrate. So your final answer will be x to the third over 9 plus c. So our answer is ln of x times x to the third over 3 minus x to the third over 9 plus c will be our answer. So the questions I get all the time is, how do you know what to choose your u as and what to choose your dv as? There is a little trick to that, so let's take a look at that. So the guideline of choosing your u in integration of parts, you could use an acronym called LITE. L stands for logarithmic function, I stands for inverse trig function, A stands for algebraic function, T stands for trigonometric function, E stands for exponential function. And you could choose your u in the order of the acronym. With that in mind, let's look at our second example. Integral of sine of x times natural log of cosine of x. We're going to start with identifying what our u is and dv is. If you follow that acronym called LITE, again, it will help us to identify what our u is. So you're given trigonometric function, you're given natural log. Again, natural log is part of a logarithmic function. In this case, logarithmic function comes before trigonometry, so your u in this case will be your natural log. And your dv is equal to sine of x dx. So we could say our du is equal to negative sine of x over cosine of x dx, which is also known as negative tangent of x. And the integral of v is negative cosine of x. So we have integral of sine times natural log of cosine of x dx is equal to u times v minus integral of v du. Your u in this case was natural log of cosine of x times your v, which happened to be negative cosine, negative, minus integral of v, which is negative cosine of x, times du, which happened to be negative tangent dx. So we have negative cosine of x times natural log of cosine of x minus integral of, again, tangent is sine of a cosine, So basically cosine times tangent will be sine of x. Question was sine of x times natural log of cosine dx is equal to negative cosine of x times natural log of cosine of x minus integral of sine was negative cosine. So that's why it becomes positive, because negative negative plus c. And here is your answer. Again, using the acronym called LITE, it will definitely help you guys to solve integration by parts a little bit easier.